Hello, good afternoon, good evening, good morning, good morrow. Is that something you say? I'm back in my echoey land. I have to clean my glasses for a special bonus live stream. So this is the Coding Train, a weekly thing that happens on the internet where I, named Dan, come and do some coding challenges and tutorials and talk about various things in the land of creative coding and that sort of stuff. If you could all in the chat, particularly in the Patreon Slack channel, just let me know if the audio and everything is fine. I'm going to keep going. Notice I didn't do I look like a different, I wonder if the white balance changed. Hopefully I look okay. It's just a different background, which is maybe. The other thing is I didn't do the intro today. This is a bonus. One thing I'll say before I get started is that I am trying now to establish a weekly schedule. And the current time that I will live stream every week is Friday mornings around 10:30 a.m. Eastern Time. I will sometimes also do a live stream on Thursday afternoons if I can manage to do 2 per week. Those are 2 open slots. And then every once in a while I will pop on here for a surprise. And so I'm just going to jump right into it today. I'll talk a little bit about how I came interested in the idea that I'd like to try to code today. I realize that people, that this channel, I don't know what I'm saying. I have a different background today. Oops, did that camera just go off? Hold on a second. Hold on, I did a terrible job of timing this as my cameras now just both went to sleep. I do have a solution for the cameras going to sleep. And I just, I haven't had the time to try it out, but someone emailed me and it's a great solution. So anyway, okay, so what's happening today? First, I would like to do, today for me is a bonus live stream. I was excited to have hit 200,000 subscribers to this YouTube channel, which is kind of mind-blowing to me over the weekend. I didn't feel so much like celebrating. There's a lot of disturbing and upsetting news going on, and so what I would like to do to celebrate the 200,000 subscribers is make a donation of $200 to each of these organizations, and I encourage anyone watching who wants to support refugee rights and support good, welcoming, tolerant, open, and happy societies, I encourage you to do so and follow along in this video. But this video is really just going to be about coding. And one of the things I thought to honor and support refugee rights, and in particular the rights of immigrants to this country where I live, who happen to be of any background, but in particular in this case a Muslim background, is to look at generative algorithms, tiling patterns from Islamic culture. And so interestingly enough, my son, who is in the New York City Public Schools here, drew this for me over yesterday actually, because he is studying something called an arabesque pattern. Now let's go to the browser. And I have a browser open. I can't find it. I have too many things open. And I'm going to go here to the arabesque Wikipedia page. So arabesque is a form of artistic, I need better eyesight, artistic decoration consisting of surface decorations based on rhythmic linear patterns of scrolling and interlacing foliage, tendrils, or plain lines. And if I look through here, you're going to see this is from 15th century ceramic panel. This is from the 9th century. And so this is from Spain. And this is, so what's amazing to me is that a lot of the algorithms or the types of tessellations and patterns and generative spirals and computational fractals and all these things that I explore in our channel can be found in lots of historical examples of art and architecture, hundreds and thousands of years before there were computers. So arabesque is one example of this. Another example is a well-known star pattern that is found in a lot of Islamic art. And here's an example from a mosque in Uzbekistan. You can see, I'm going to zoom in on this because this is a very high-resolution image. And you can see these beautiful, beautiful tiling star patterns. And if you look at the work of M.C. Escher, if you Google and look at any sort of computational algorithms for repetition and tiling, and a great resource for this is Rune Madsen's printing code, and this is, I'll include all the links to all of these in my, I will include all the links to these in the description for this video, but this is a particular lecture from Rune Matsson's Printing Code, where he goes through a series of algorithms for repetition and tiling, aperiodic tiling, and you'll see examples in graphic design. So these are some great examples of using substitution rules, and I encourage you to check this out for some code examples. And I also, one of the things that I love that I would love to do is that somebody remind me as a future coding challenge is hyperbolic tiling. And this is a particular kind of tiling that algorithm that you can perform on what's known as a hyperbolic plane. So not a flat surface. And you can see this sort of almost like infinite recursive tiling patterns of different polygonal shapes. Is that how you say that? Going out towards the outside here. So this is some inspiration and some things that I've been looking at over the last week. Really actually over the last few days. I've often looked at these algorithms and thought about implementing them. So however, the thing that I settled on trying to do today, oops, I need that Paul Bork site. Paul Bork, point line plane. I'm going to come back to that. The thing that I settled on for today is, oh, and I've lost this link. Hold on, let me find it. Star patterns algorithm. This is a paper from Waterloo Computer Graphics Lab in Canada, and the particular paper that I read/scanned is called Islamic Star Patterns from Polygons in Contact. And I'm going to diagram this for you and try to understand how it works. And we're going to see if we can write some code to generate these beautiful star patterns. I am going to make a shared GitHub repository that people could contribute to, and we'll create a lot of beautiful, hopefully, generative star patterns and creative variations of these together here on the internet in this world together. So, where am I here? So let me open up this paper, which I already downloaded. My phone is buzzing, and here we go. Oops. And let me open this up here. So we can see here, and I'm going to just full screen this. So you can see here what the idea that I need to look at is to kind of think about how polygons work, how I might create vectors that emanate from sides of polygons, shift those around, change the angle, and then tile those to get patterns that look something like this. And one of my, scanning through this one I really particularly like. It's quite nice. And so there's some interesting visual variations on this. So I'm going to try to do a very simple one where the polygons are just squares, and I use kind of a fixed angle to just get the system going. And then my hope is that those of you watching, as a challenge to you that we can collaborate together on, would be to vary the kinds of tiling, to vary the angles, and to see what we can do with color and that sort of thing to generate a wide variety of possibilities. And you can see here are some, oh, this is a really nice one too, some different possibilities. Okay, so that's kind of my plan. I am going, it's about 4 o'clock. I was hoping to be done with this by 5, so see if we can do this in about an hour. This is actually a little bit different because I did code this in advance. So I have a semi-working version of the basic idea here because I was a little bit afraid to just kind of do this on the fly. And that's usually my style. Is the point of my coding challenges. I don't do them in advance. But I'm still going to code the whole thing from scratch. But just to show you, the one that I did in advance is right here. And this is just a really basic grid pattern where these rays are emanating, intersecting, and creating shapes out of the grid pattern. And I can vary, this is me varying the angle, and this is me varying something called the delta, which I will explain as I go through the algorithm. So luckily, when everything goes wrong, I'll have this to refer to if necessary. And then, but I'm going to put that aside, and I'm trying to decide, I might do this in two videos here. So one will be a standalone coding challenge just about finding the intersection point between two lines, which is useful, although I don't know how much I really feel like deriving that formula today. I kind of just want to copy it from here. So I don't know. So that's kind of what I'm thinking about. I'm looking at the chats to see if there's anything I've missed. This one doesn't seem to be scrolling. Oh, yes, it is. Okay. Oh, no. Okay. For some reason, the Slack chat doesn't scroll when I don't have it open, but I'll try to see if I can fix that. Okay, so I can take, before I get started, it's 3:55. I feel like I'm going to start this at 4. I can take and I'm going to minimize this to leave these links open. I can take, I'm going to stand over here. I'm going to look at the chat. This is where I have a window to the chat here. I'm going to see if there are just a few questions, general questions about programming this channel that I can answer, and then I'm going to get started with programming these algorithms. Okay. So I'm looking at the chat. I'm going to drink some water here. What else do I need to think about that I might be forgetting? So I think what I'm going to do, by the way, is I am going to get more monitors. I am going to not do a separate video about line-to-line intersection. I'm just going to grab that formula really quickly and put it in the code when I need it. And then if I have time later this week, I'll come back and do a video about that and actually derive the formula. Okay, there's all these questions now. Can I program something in Java? Probably not today. I'm going to do this in JavaScript so that it can live on the web, which is easier to bring back the beard. Yep. You know, I felt the need for a fresh start. Can I compute the symmetry group of a tiling? That would be an interesting variation. Wow, how many people are watching, by the way, right now? The train sound, yes. You know, I don't know why I felt the need. If I felt like I wanted to sort of do this as a fundraiser, and I don't know. I felt the need to not be so ridiculous, but there we go. Okay, is my hair green? No, but there might be there is a green screen behind me that I will show you right now for a second. So this is what I actually look like in the room that I'm standing in. And I have 2 laptops up here, one where I'm looking at the chat and one where I'm coding on, and a green wall behind me. So that's probably what is making my, can you hear me, by the way, when I go into there? Audio, so yeah, the audio is still going in that realm. Yep. Okay. Okay, so that was some good questions. I'm gonna just move on now to start doing the coding challenge. So let's get myself set up. So I have do I have Atom editor? Like first, let me quit processing. I don't need processing open for this. I am going to sing for no reason. I'm always afraid, by the way, in this room, that someone's going to knock on the door saying that my noise is really disturbing them. So let's see if that happens. Okay, okay, so what I want to do now that I have Atom open is in star patterns. That's the I'm just going to open up star patterns here in Atom. This is my live one. There's this like GitHub repository. Whoops, I don't know what I just did. I'm going to call this sketch.js. And I am going to take out all these other references. And in sketch.js, just add function setup. Function draw. And create canvas. 400, 400, and I just want to see background 51. Actually, to be honest with you, let's just do all this in setup to make it static for the moment. And now I'm going to go back to the browser, and I'm going to have this open. Whoops, nope. Come back to me, computer. Come back to me, computer. Come back to me, computer, with the morning in the sun. Hey! Okay, never mind, sorry. Okay, live. Here we go. I need a console open. Okay, refresh. And I think I'm in pretty good shape. So I've got this open. I might need to move this a little bit more here. I'm going to move this a little bit more here. So now I have this open. I'm going to turn this way. Okay, and I have the code. I'm nervous here. Now I have the paper. Let me open up this is my 8-year-old son's drawing of an arabesque pattern. And now I'm looking for this. Okay, so I need this open. So Atom, this, And that's good. Okay, so I think we are ready to go. And I am going to, what I would like to do is hide everything for just the moment. I'm going to say something at the top again just about what I'm doing here, and then I'm just going to get started. I have all this mess over here. Let me get rid of this mess here. Put that stuff in there, put that stuff in here, stuff in here. So I'm going to leave this here. I need that here. Soundboard, I don't have the soundboard open right now. And then clean up. And I need to stand over here. Yeah, over here, while the video starts. Okay, let me press these buttons on the camera to give them a half an hour. And I think I'm going to do the usual thing, even though this is all I'm doing today for the most part, which is that I am going to code this pattern, going to publish it to GitHub, and then I assume this will be, I will have all sorts of problems and stuff, and then, and you know what I'm going to do? I'm going to do the thing where I do an intro afterwards. So I'm just going to get started, and I will, in the intro afterwards, mention some of these organizations. Okay, and I'm just looking in the chat to make sure, why is this not scrolling? That's super annoying to me. Sorry, I have to change something. So I'm going to put the YouTube chat back on this computer. There it is. And then I'm just going to only have the Slack channel on this computer because the Slack channel doesn't scroll unless it's in focus, I just noticed. So now I can see. I need to move this over. Sorry, everybody. Where did this get? So I can see it better. Then I need to just click in here. Click here. And I am good to go. Hungand in the chat asked, can I please make Minesweeper in a future coding challenge? And to be honest, I would love to make Minesweeper in a future coding challenge. That's a great idea. It's on my list. I want to get started on the challenge, but it's useful for me to mention that I do have a GitHub repository called, it's at this URL here, codingtrain/rainbow topics. And right now, if I search for Minesweeper, I'm sure it's Minesweeper, all you've got to do is give your thumbs up here, and I try to take a look and see if a lot of things have a lot of thumbs up. I'll try to get to it sooner. But mostly I just pick whatever I feel like doing or whatever related to the course that I'm teaching this semester. But I love the idea of doing Minesweeper, so I will try to do that. Okay, let me close that. Let me minimize this, and let me get started. Actually, so I'm going to leave this up for an intro that I'll do later. So I'm actually going to open all this stuff up and open the paper. Okay. Everybody ready for this? I'm excited. Just checking my phone to make sure there's no like the world is ending emergency messages. So all aboard. Okay, here we go. I'm going to move some stuff out of my way, and we're just going to get started. I hope this goes okay. Oh, wait. I don't have my marker. Let me just check and make sure. How is the whiteboard view looking to everybody today? Does this seem in focus? Does that seem okay to everybody? Please let me know, because this is definitely going to require some diagramming. I need the eraser. All I need to do is find my eraser. Then we're really starting. I can't find my eraser. It's got to be here somewhere in this room. Where, oh, where has my eraser? I found it. And here I am. I'm going to erase this. And come back. I have an eraser. I have a marker. All good. All good. I'm over here. And here we go. Okay. Bit more focus needed. I'm seeing 9 out of 10. 9 out of 10 viewers of the Coding Train recommend the current focus. Okay, maybe write larger. I will write larger. Okay. Now, I have to admit something. I did read over this paper, but I don't really remember it. So today in particular, I'm really looking for you guys watching to help me out, because this is going to be a tough one. And I also have a feeling I'm not going to do it correctly. In which case, the whole point of this is just to inspire and give it a try. And we're going to, I'll come back on Friday, and as people give me pull requests and fix things up, I'll reference it again. Okay, here we go. How am I doing? 20 minutes. This stream has only been going for 20 minutes, and I'm actually getting started writing some code, which is pretty good for me. I've had like an hour and 15 minutes of rambling before I actually started doing anything. So, okay. Okay, I am looking at the chat, Ghost from Pac-Man. It is too hard for me to follow the chat. Someday I will have a different system, but I will take a peek. And as I take little breaks while doing the challenge, I will also take a peek and ask and see if I can answer questions or. Yes. Okay. So here we go. Thank you. Hey, little PSA. Stay hydrated. Today there is no sponsor of the coding train. I will be accepting sponsors today. This coding train is sponsoring these wonderful organizations. I am giving a donation, and I hope that you will consider giving one too. But if not, just enjoy watching and be inspired and contribute to the world in good ways through open source and code and that sort of thing. Okay, but stay hydrated. Everybody, you've got to stay hydrated. All right. I have this remote. If I press the remote, it should tell the camera not to go to sleep. But it doesn't seem to work. Okay, does anybody know how you pair one of these Canon remotes with a Canon camera? There we go. Okay, I am ready now to work on this coding challenge. And this coding challenge is based on Islamic star patterns from polygons in contact, a paper from the School of Computer Science, Craig Kaplan, University of Waterloo. And I'm not going to, as much as I would like to just do a dramatic reading of this paper, I'm mostly just going to follow the diagrams in terms of this challenge and try to work on coding stuff out, and those of you are encouraged to read the paper and point out everything I did wrong in this particular video. So I'm going to refer to it when necessary, but this is the main component here of how this is going to work. And I'm going to start with a diagram. So this is a diagram here, but I need to draw this myself in order to understand how this works. So the way that this algorithm works is if you have some regular tiling of polygons, and you can get very complex and sophisticated with this. I'm going to build a really simple example. My tiling will just be a grid. So I want to have in my canvas a grid of squares. And then if I pull out one of these squares, what do I do? Any polygon has a certain number of sides. For each and every side, I want to find the midpoint. This is the midpoint. Then what I want to do is send out a ray, a vector, an arrow from that midpoint, and based on some angle of rotation from the side. So the angle that I'm going to use to start with will be 60 degrees. So if I send these out, oh, this is like a bad way that I've drawn this, because it's going to work out so too perfectly. So, and then as these go out, the ray that they intersect with first, most closely, they stop. So this actually, weirdly enough, the way that I drew it created a square, but let me make it different. So what if I do this? You could imagine seeing something like this. Boy, my drawing skills are terrible. But you can see here I'm starting to get a star pattern. So based on that angle, I get a star pattern. And incidentally, if this is tiled next to another polygon, this is going to go out this way. And if I make my polygons something more interesting, like a hexagon with maybe, a couple smaller hexagons, I could come up with some clever, or some triangles. You could imagine that this is also going to give me even more interesting patterns. And the idea here is that then, once I do that, let me get my eraser. Once I do that, I erase that original grid, and I'm left with these star patterns. So this is the idea of recreating one possible algorithm to recreate this style of star patterns based on a grid of polygons that are in contact with each other. So that's what I'm going to try to build. So coming back over here, the first thing that I want to do, and you can see this, there's an important aspect of this that I didn't explain, which is that, notice the way that I drew it, these rays are going to come out from the same point in the midpoint of the side of a polygon, but the paper talks about a value called delta. If I separate those rays by a little bit, then I get further, I'm further playing with the pattern and making it more beautiful and interesting and star-like in ways. So I'm going to also need to introduce this delta as well. Okay, so here we go. I see in the chat that there was a little sound glitch. Hopefully it wasn't too disturbing, but if that continues, please let me know. I'll keep an eye on that. Thank you, Alka. I guess about you could edit out that little when this gets edited together. Okay, so the first thing that I want to do is I want to create. I think what would be useful is to have. I'm going to do it this way. By the way, I should mention this technique is referred to as. Let me try to find it as the Hankin method. And time out here for a second. Given a tiling plane, Hankin. I forget where that comes from. Footnote 12. Can I click on that? 12. Show me 12. Oh, Hankin, the drawing of geometric patterns in. Anybody know how to pronounce that? Saracenic art? Does anyone know how to pronounce this word? Okay, so I want to just mention that. So I'm going to do that here. Okay, nobody is giving me a pronunciation yet. I'm waiting for that to continue. I just have a little sip of water here. It's too bad that the chat is many seconds behind me. Okay. Thank you, Lazaro, for saying this is awesome. Oh, look at this. How come I don't hear this? Oh. Sarah Keat. Hold on. You guys. Saracenic. Okay. Saracenic. Is that right? Worst thing is I get it wrong. Thank you. Okay. E as in letter. Saracenic. Okay, great. Okay, sorry. Thank you, Mathieu, for being so wonderful to always help edit these things. Okay. So one thing I should mention is from this paper is a discussion of a system called Hankin's method. And Hankin's method, I'm going to just click on this footnote here into the paper and take a look at it, is another reference here called The Drawing of Geometric Patterns in Saracenic Art. Volume 15 of the Memoirs of the Archaeological Society of India by E.H. Hankin. So I'm just noticing this now. I would love to dig up a copy of this and read this as well. So this paper is also based on, yet again, something else. So this is called Hankin's method, and the reason why I thought of that is because I'm going to need to have a few different objects. So one thing I definitely want is to have a polygon object. A polygon object describes this entire polygon. Then maybe I also might like to have an edge object. An edge describes an individual edge of the polygon. 1, 2, 3, 4. And then I might could be useful to create what I'm going to call an object called a Hankin. And I hope I'm pronouncing it. It could be Hankin, which is just these object to keep track of these rays that I'm going to cast out from the sides of the polygon. Okay, so that's going to be how I'm going to organize the program. At least how am I thinking of it now. So I'm going to create a polygon object, and the polygon object is just going to have an array of edges. So I also need to have an edge object, and I'm going to have every edge is a line. I'm going to keep track of the endpoints of that edge, and I'm going to call them A and B. So perhaps what I'll do is, and I guess I'm going to make these all variables that are public and available outside to view in the object. So I'm going to say this dot show equals function. And actually, what I'm going to do, eventually at some point I want to do something different so I can fill these with color, but just for simplicity's sake, I'm going to loop through all the edges. And say edges index I dot show. So an edge will also have a function called show. So to show a polygon, I just say, hey, draw all the edges. And to show an edge, I say stroke 255, line from this dot A x, this dot A y, to this dot B x, and this dot B y. So I'm starting by making this idea of polygons and edges. And eventually I'm going to put these into separate JavaScript files as the code starts getting bigger and bigger and bigger. But just to start right now. And then maybe what I will do is I'm going to create a function called add vertex. So what I'm going to do is for add vertex, I am going to add an x and a y. And then I want to create a point called a, which is a vector at that x and y. And then, you know what? It wouldn't hurt. I don't know if I need these, but it wouldn't hurt to have an array that also just keeps track of all the vertices. I might not need that later, but right now I'm going to just do a lot of stuff that's redundant just to kind of figure this out. So what I'm going to do is I'm going to say this dot vertices dot push that vector. So the first thing I want to do is when I want to add a vertex to my polygon, I want to give it an xy where it is, make a vector out of it, and add it to this array, this list of vertices. Then, as long as, and let me do this first, as long as there's already at least one other vertex in the, as long as there's one other vertex at least in the list already, I can make an edge. And you know what I should do? The way that I make an edge, oh yeah, that's how I did it. Okay, the way that I make an edge is I would say previous equals this dot vertices, and you know, let me put that in a variable. So how total is this dot vertices dot length. So I now have, how many vertices do I have so far? As long as there's at least one other vertex, previous is index total minus 1. So you can see I want to look at the previous vertex. And then what I want to do is I want to make an edge, which is between what? The previous and the new one. So then I add, and then I can add this dot edges push edge. So I'm kind of writing a lot of code without even running. Let's just see if I have any errors. Refresh. Okay, so I have some errors. Sketch.js line 11. This equals function. And there we go. So now look at this. What I have so far is this idea of a polygon object. So I have a polygon object, which is a generic polygon. Could be a square, a trapezoid, a hexagon, a heptagon. And what I want to do, by the way, hyperbolic heptagonal tiling. That's a cool thing. Look that up. So I can add vertices. Have an x, have a y, have an x, have a y, have an xy, have an xy. I can add them, and it'll create edges, and then I can display it by saying edges.show. And an edge is just a really simple thing. It's 2 points, and I can display it as a line between those 2 points. So let's try making one polygon, a simple one. Okay? So I'm going to create a variable, poly equals, called poly. And I'm going to say poly equals a new polygon. And then I'm just going to add some vertices to it. Add vertex 100, 100. Add vertex 200, 100. Whoops. Add vertex 200, 200. Add vertex 100, 200. And then poly dot show. Ready? Let's just see. So if I did all my code correctly, I should see just a square on the screen. Okay. Poly dot error edges is not defined. Oh, everybody knows. Just everybody sing along with me now. This dot, this dot, this dot, this dot song. I'm sure that's what it is. What line was that? Line 32. Yep. This dot edges dot length. this dot edges show. I'm sure I'm missing more. X is not defined at sketch.js line 45. Oh, interestingly enough. Okay, hold on. Now there's some more. There's actually like a real bug here, because if X is not defined here, what's going on? So let's look at what did I miss? This dot B. Okay, so let's look at what I missed where I'm creating the edge. No, so you know what? To debug this, I feel like now I already need separate JavaScript files because I'm doing that horrible scrolling thing. So I'm going to create a JavaScript file called polygon.js, and I'm going to take my polygon constructor function, and I'm going to put that in here. Then I'm going to create a file, and I'm going to call, no search. I'm going to create a file, and I'm going to call it edge.js. And I'm going to go to Sketch, and I'm just going to take that. It has very little code in it. But this is going to make life a lot easier to try to figure this out. So let's look at where I make the edges. This is where I make the edge. This dot add, A is a vertex. Previous equals this dot vertices total minus 1. This seems sort of reasonable. Let's console log this edge and see if those look like they're supposed to. Whoops, I didn't even get that far. Sketch.js, var A equals create vector xy. In the chat, hold on, I'm getting a bunch of nice, error messages. Hold on. Third argument, line 45. That doesn't seem to be my problem now. This dot B, okay, well, let's take a look at that. Oh, I've already moved on and separated the files. Oh, I forgot to import them. Thank you, yes. Oh boy. So, of course, I need to also make sure I reference edge.js and polygon.js now that I have added those. Okay, edge, edge, edge. So that's working. And then edge.js line 7. So this edge is fine. A and B are two vectors. That makes sense. This edge looks fine, A and B. This edge looks fine. How come I didn't get that fourth edge? Oh, 1, 2, 3. I need a fourth one because I need to, let me think about this. Still, there's a typo. Error in the edge is, so let's look at what the error is. Edge.js line 7. Edge.js line 7. It's getting something. Oh, there's just like a ridiculous error here. Oh my goodness. You guys are all telling me this. I just missed it. Okay, there we go. There we go. So this is promising because I don't have an error. However, there's a bit of an issue here, which is that I don't see my square. So why don't I see my square? Let's take a look and try to figure this out. Am I calling poly.show? Okay, so in poly.show, is this actually happening? Let's just see if that's happening. 0, 1, 2, that's a good sign. So now let's go into the edge and look at show and say console.log this.a, this.b. Do I see something? So this looks good. Why? There's no reason I can't imagine why I don't have a line between these things. I'm trying to make this a little bigger for you guys. Maybe this is a little smaller. There we go. So what's missing here? Stroke 255. Stop coding and read our message. This dot B. Oh, I have an extra this dot B in there. Oh my goodness. Lost my mind. Thank you. There we go. We've got our square. I'm not sure. Maybe you want to do some editing there. Okay. I'm going to look at the nice Slack messages more closely next time. Thank you, guys. Okay, so now we have, I knew this line looked a little crazy, but now the thing is, where's that last edge? I need to get that last edge. So what I'm going to do, if we look at the polygon, is I really should connect the first one with the last one. So actually what kind of makes the most sense is, there's a bunch of different ways I could do this, but I think what I'm just going to do is, I'm going to write a function called close that I can just call. that just says var edge equals a new, let me get the last one. There's probably a JavaScript function that will, like I can do like pop or something like that, or shift that just gives me the last one of the array. But here I could just grab the last one, and then I can say the first one, this dot vertices 0, and I can make a new edge from, and now wait a second, I'm going from previous, if I think about this, square, hold on, let me erase this, because for a while we're just going to want to work with one square. If I am thinking about this one square, I connected previous to here, then I connected here to here, then I connected here to here. So I want the last connecting to the first. And so what I'm going to do that is I'm going to say I want the new edge, the last connecting to the first. And now edges.push edge. And then what I just need to make sure I do is in the main sketch, when I'm finished, I'm going to call that close function. So in my polygon object, and by the way, I'm sure there are some great geometry library that we could just use that would do all this for us. So I look forward to your fork of this that makes it much nicer with a sophisticated geometry library. We should see, edges is not defined because, as you can all say with me, this dot, this dot, this dot, this dot's on. Okay, great. What is this? 10 minutes and I got a square on the screen? Boy, aren't I really such a exciting and interesting and engaging coder to watch. Okay. So we've got a square on the screen. So now, what do we want to do as the next step? The next step that I think would make sense is for me to start making these, what I'm going to call the Hankin or the Hunkin objects. So the first thing I need to do is figure out how to find the midpoint for each side of the polygon. And again, I'm using just a square to do it in a simple way, but however I program it, I want it to be generic that it would work as soon as I change the square into, say, a hexagon or some other type of polygon. So let's first look at those midpoints. So what I'm going to do now, I think, is in the edge object, I'm going to write a function called this.Hankin. Hankin. And in this function, the first thing that I'm going to do is find a midpoint. And the way I'm going to find the midpoint is I'm going to add this dot A and this dot B together. And then I'm going to say mid dot multiply 0.5. So this is a function in the P5 library that takes two vectors and adds them together. And then multiplying by 0.5 is dividing by 2 because the midpoint is essentially the average of the 2 points. So that's going to give me the midpoint instantly. Excellent. Now, here's the thing. I want to, the other thing that I need, so what is a Hankin? What is a Hunkin, a Hankin? Somebody in the chat try to figure this out. Okay. So here's the thing. I want to keep track of array, essentially. So I need a starting point, and I need a vector that's pointing in a given direction. So that's what I want a Hankin to be. So I'm going to come back over here. I'm going to make a new JavaScript file, because I'm overdoing my objects here. And I'm going to call it hankin.js and function Hankin. And I know a Hankin should have a starting point, which I'm going to call A, and a V, which is the vector of the direction it's pointing. So this dot A equals A, this dot V equals V. So this is ultimately what I want to create. So in the edge, I know I want a midpoint, and now I need an array that points in a certain direction. Okay, so, oh yes, thank you for the reminder about importing it. Okay, so if I could get a vector that points from here to the end, or from here to the end, right? If I have vectors that point from here to the end or here to the end, time out just for a second. My phone, for whatever reason, is set up with a notification, and it's making me totally crazy. It's just buzzing constantly. And so I'm not even, wrong camera. Good thing I noticed that. Thank you. Okay, hold on. I noticed the wrong camera. Okay, hold on a minute. I have got to fix this issue with my phone. Can I put it to sleep? I'm just going to put it in airplane mode. Okay, because it's so distracting. Okay, so now I'm going to do a little backwards thing here since I did the wrong camera, and I didn't draw anything yet. So, except for maybe this. I know you can't see me right now. Okay. Okay, here we go. Now I'm going to walk over, and actually while I just have a second here that I took a little pause, I'm going to press the buttons on the cameras so they don't go to sleep. Oh, this one went to sleep. I do have new cameras. That one already went to sleep. They go to sleep, unfortunately, still. I have a solution for it. I just didn't implement it yet. Okay, here we go. Now I'm going to go back to where I was. Okay, so if we look at this diagram, what I want from this midpoint is a vector, two vectors, one going out this way, one going out this way. So if I could just get a vector that points from here to each of the endpoints of the edge, then all I need to do is rotate it by some angle, and I have the two Henkins. Okay, so let's try to do that. So what I need is the midpoint and the edge points. But look at this. I have the edge points are A and B. The midpoint is, I just calculated. So I should be able to say now, var v1 equals p5.vector subtract this dot A, the midpoint. So this creates a new vector. And by the way, a lot of this could probably be optimized with creating fewer vector objects and reusing them, but I'm kind of not going to worry about that right now. I could always come back and optimize and clean this up and make it more efficient later. So I want to say, give me a vector. The way I get a vector pointing from one location, A to B, is I just say B minus A, and then I've got a vector pointing there. So that's one, V1. And then V2 is pointing from the midpoint out to B. So now I've got a Henkin for some Henkin, I guess. I don't know, never mind. I stole that joke from the chat, by the way. Not that that's a joke. Not that that's funny, I guess. Apparently I make dad jokes. Is that what it's called? Cringe is now being typed into the chat. So I am going to now say var h1 equals, and actually what I'm going to do is I'm actually going to give the edge a reference to two Henkins. And I'm going to say this dot h1 equals a new Henkin from A to with a direction of v1. This dot h2 is a new Henkin B to v2. Okay. I think this is good. So now, why not when I call show, let's just say this dot h1 dot show, this dot h2 dot show. So when I show the side, the edge, I'm also going to show the Henkins that are emanating from the midpoint of that edge. And the Henkin function then needs a show function. And there's a lot more that I need to add to this. But just for right now, what I'm going to do right now is I'm going to say this dot B equals P5 vector, add A comma V. So what I want, right, remember what I have is I just have, can you see this over here? I just have a point A, and then I have a vector V. But what I want to do to be able to display this just for debugging is I want to have a point A and a point B that I can just draw a line between. So if I take A and add V to it, now I have point B. And actually what I'm going to need to do is, this is actually a little bit of a problem because it's I know it's fine because the Henkin vector has an arbitrary length. I'm going to need to normalize that vector and make it length 1, but we're getting there. This is just for debugging. I'm now going to say stroke 255, line, this dot A dot X, this dot A dot Y, this dot B dot X, this dot B dot Y. So that should also draw a line. So here we go. Now in the sketch, I add vertices, and I close it, and then I should probably say I need to calculate all the Henkins. So I have a lot of function called Henkins here. I'm going to say poly.Henkin. So I need to add a function to the polygon, which all it does is it loops through all of the edges, which I already have a loop, and has each edge call the function Henkin to calculate its Henkins. So basically, right, I have almost this hierarchy. The polygon is the overall shape. The polygon keeps track of a list of edges. And then each edge keeps track of its starting point and end point and the two rays emanating from it. So what I'm doing is saying, hey, polygon keeps track of the edges. Hey, all you edges, calculate your Henkins, so to speak. So now if I refresh this, Henkin is not defined. Import, I forgot the import. Everybody was reminding me in the chat, and yet I forgot it anyway. So I need to add Henkin.js. I'm going to hit refresh. Interesting. This doesn't look right. Oh, okay. I'm definitely going, I think I messed up the midpoint calculation. So let me think about this. Pause. I made myself tic-tac-toe. Alka, I'm also going to steal that joke. Okay. I think that I did something wrong. I mean, I definitely did something wrong. Let's go draw in, let's debug this for a second. I don't know, this can maybe be in the video, we'll see how it goes. I think the midpoint is something's wrong with the midpoint. So let's go and take a look at how I did the midpoint. So midpoint is in edge. Oh, no, oh, yes, okay. So let's just for debugging's sake, okay. Isn't that, can I add 2 points together and then take the average of them and that's the midpoint between them? Yeah, that's correct. So I don't think the midpoint is wrong. Oh, I bet you I know what's wrong. I think I know what's wrong. I think it's actually just a visual issue. So one thing that I want, let's just do something for a second, which is let's rotate it by each one by 60 degrees. And, yeah. And just to see, I just want to see something for a second. Let's rotate by 60 degrees. And while I'm doing that, I want to work in degrees just for, and so I'm going to say angle mode rather than radians. Natively, JavaScript, P5, et cetera, is going to think in terms of radians, but I can adjust that by using angle mode degrees. Yeah, okay. This is actually a bit more like, so something is way off, but we'll fix it. I'm not worried. Apparently my just doing this from out of my head turned into craziness. So one thing I want to do to just more effectively debug this is when I draw the Henkins, I want them to be like some sort of color. So let's make them blue, just so we can easily distinguish. And that's kind of an awkward color. So let's make it a little bit brighter. Okay. So these, first of all, they're in a weird place. They're not emanating from, the midpoint is definitely off. I didn't rotate the lines, is someone in the chat saying. I think so everything is all crazy. So first thing I want to do is just also now draw ellipse at this dot A dot X, this dot A dot Y with 8 and say fill 255. Okay, so let's look at this. So for whatever reason, my midpoints are definitely off. So I'm going to have to take a look at this. The midpoint calculation is off. What have I done wrong here? Pause. Henkin mid, not A or B. This is an edge between A and B. Oh my goodness! No. No, that's not it. Oh, this should be mid. This should be mid. What was I doing? These need to be the midpoint. The whole point of this was to draw them emanating from the midpoint. There's the problem. Okay. I don't know if I need to. Okay, so here we go. There we go. So now you can see they are emanating from the midpoint. Now this is right, but they are rotated in a very particularly strange way. So let's take out the rotation for a second and just see if what I'm getting is what I think I should get. Yeah, so this is what I expected to get, which is that I just have these vectors pointing away. So let's just rotate one of them. Well, obviously one needs to, they can't both rotate 60. One needs to rotate negative. So that's probably the problem. Okay, so this is not right either. So I want to rotate it by negative 60. Let's try that. So this looks right. This looks right. Why? What's going on here? Why did that rotate in a strange fashion? Yeah, I'm pretty sure that it's degrees. It should rotate from the I'm just rotating the vector. Am I, let me just see something here. So I rotate V1, then I send it to Henkin, and that's that. Then these are two different vectors. Right? No, you know, is it really doing it by, let's just double check. Okay, who knows? Maybe angle mode degrees and radians is broken. So let's do the conversion ourselves, just to be sure. Yeah, that was the problem. Angle mode degrees doesn't seem to work properly in P5 with the vector rotation function. So I'm going to have to investigate that. It's probably a bug, although I could have done something wrong. So I need to investigate that and submit it. I actually think that I implemented this part of P5, so if it's a bug, it's because I did it incorrectly. Because I implemented a lot of the vector stuff a long time ago, I think. Anyway, so now let's rotate V2 by this. By, oops, and I'm missing parentheses. There we go. So this is perfect. So look at this. We're already kind of golden. What we have now is the Henkin objects, and they are emanating from the midpoints at 60 degrees. And we can see that what I would like to do right now is just make this a variable. I'm going to say angle equals 60. And then in the edge object, I want to rotate by negative angle and positive angle. Oops. Negative angle and positive angle. And what I'm going to do, hit refresh, same thing. Now we should be able to do things like, okay, let's make it 30 degrees, and we can see it looks like this. Make it 90 degrees, and I get that. So everything is working as expected, and I'm going to stick with 60 degrees. Now here is the thing. What we actually need to do is find this point. Am I pointing at it? I'm pointing at it. We need to find that point of intersection. And while it's quite simple to look at this and just say, well, this one always intersects with that one, and this one always intersects with that one. So we could kind of know it's not going to be so simple if I start to vary this delta value I referred to earlier, or vary the way the polygon. So I need a generic way of doing this. And the way that I'm going to do that generic way is I'm going to, for every one of these rays, let's do this as a diagram. Okay? What I want to do is I am going to, here is the square, and I have this midpoint, and I have this pointing out of it. And let me make it point a bit more towards the center. So what I want to do is I'm going to ignore its friend over here, its partner that's rotating the other direction. I don't care about it ever intersecting with that one, because it's never going to. When they cross, they might, but I don't want it. And now what I want to do is I want to look at every single one. So two lines always have an intersection point, unless they're parallel. So what I want to do is shoot this ray out, shoot this ray out. I can shoot this one, I can shoot this one, I can shoot this one, and I can shoot this one. So what I want to do is I find all these intersection points. And I think the way to find the correct one, right? If I just say, where does this ray intersect with all these other rays? If I find the correct one is the one that minimizes the total distance of these two. So in other words, even though it intersects with this one first, if I add up these two values, it's going to be bigger than adding up these two values. I think this is the way to do it. You guys in the chat, think about this, and we're going to see what results I get. And then also, frankly, after this video is done and there's a GitHub repository, we can iterate and optimize this. Okay? So this is what I'm going to try. I'm just pausing for a second, because I see a message in the chat from Alvaro. It's better to compute a point. Oh my God, the chat scrolls way too fast. I lost that wonderful message. Can I scroll it? Let me try to scroll back up. It's better to compute a point from each vertex to the center using center lerp vertex 0.6. I could just start to actually grow them. I think the paper talks about growing them and then determining, oh, there's all these formulas in the chat. The length should be L divided by 2 cosine alpha sine alpha length. Yeah, but I'm not necessarily going to have a square later. So Jamie does an excellent suggestion in the chat, but I don't know that I'm going to have a square later. But here's the thing. The paper, I read the paper, and I believe the paper talks about growing them. And so I could grow them and just wait for them to intersect. And I believe this would hit that one before this one got there. But that's kind of the same thing. And it would be interesting to make it animate and grow and sort of test. But I think I'm going to try to do it the math formula way, I think. So, so I'm going to keep going. And some people in the chat, by the way, are asking about begin shape, end shape. That needs to come into play later, because I need to make these polygons that I could fill. But I'm just trying to work out the math right now. Okay, so this is part that won't go in the actual tutorial. So I'm going to come over here. And I'm going to fake walk back to over there and keep going. OK. So, oops. So what I need, by the way, is a formula to calculate the point of intersection between two lines. And thankfully, I have a website. I knew that I would need this. I have a website loaded already. I will link to this in the video's description. paulbork.net/geometry/point-line-plane. Paul Bork's site has tons of geometry formulas, and I would like to do a separate video to maybe kind of derive this. But what I'm looking for here is the intersection point of two line segments in two dimensions. And so this is actually what I need to do right here. If I have P1, P2, P4, P5, P1 being X1, Y1, P2 being X2, Y2, P2. I can use this formula to calculate these two particular values, and then I can find the X and Y intersection point with these two formulas. So what I'm going to do right now is I'm just going to take a screenshot of this, and we're just going to implement this formula in the code. And someone remind me if it's interesting. I can try to do another video to sort of derive the math for this a little bit more. Whoops, let me look at the desktop. And I'm going to open up this screenshot, and I'm going to leave this. Oh, look at that. I didn't do that correctly. Sorry, everybody. Let me try that again. And I'm going to make a little screenshot here, and I'm going to leave this open just as a reference that I can look at as we are writing the code. So let me come back, and what I want to do now is in Henkin. Okay, so what do I want to do? The edge object keeps track of two Henkin objects. So this is creating the Henkins, and then I'm going to write this dot finalize Henkin, or I just call it find end is a function. So find ends. And what I need to do is I need to look. Here what I need to do is look for every single, okay, so what I need is all of the other edges. So I need to receive, this function needs to receive all the other edges. And I need to say, for var I equals 0, I is less than edges dot length I plus plus. So first thing first is I only want to do this if this object is not equal to, you know what I would rather do here for a second? Let's make this simpler. I'm going to make this function just receive one edge. We'll deal with this later. Right? So what I want to do is I want to find this, where does this particular Henkin intersect another one? Edge dot h1. Or where does it intersect edge dot h2? And then the same as I need to test all of these. And h2. So there's a lot of tests going on here. Each one, h1 and h2 of this object needs to check the other objects h1 and h2. So actually, I think what I'm going to do, I'm going to say this dot h1 find end edge dot, I'm going to just pass this off to the Henkin object. This hierarchy thing is a little bit out of control, but I think it actually makes kind of sense. So then I want h2 to check both of these. So for this function, right, again, the polygon is going to say every edge has a bunch of Henkin objects. For every Henkin, send to the edge the other Henkins. And then the edge is going to say, hey, you Henkins, work it out amongst yourself. So I'm kind of peeling this back. So now what I need is in the Henkin object, I need a function called this dot find end equals function to some other Henkin. So what I need to do, this is now where I need to do line intersection. Where do those lines intersect? So that's where I need this equation here. Now, interestingly enough, look at this. Let's think about this for a second. I'm going to need to diagram this. This is hard. What time is it? I'm getting hungry. I'm getting hangry. Where's my? I'm hangry. But that's my happy and angry. No, hungry and happy. Hangry. Anyway, whatever. Okay, so let's say I have x1, y1, and I have x2, y2. And then I have x3, y3, and I have x4, y4. These are the 4 points. What I really have in my program is x1, y1, and a vector that points to here. What I really have in my program is x3, y3, and a vector that points to here. So anytime I see in this particular thing, anytime I see x4 minus x3, and I have to thank MeIamSome on Twitter, who helped me with this suggestion as I was trying to work some of this stuff out earlier today. X4 minus x3 is actually that x value of that vector, right? Because, oops, I don't actually need to calculate x4 minus x3 because that's the x component of that vector I have already. So there's a lot of ways I can actually reduce that formula and make it a little bit simpler. So let's see, I'm sure I'm going to get this wrong, but hopefully those of you watching in the chat are going to be able to help me correct this. So let's see if I can now translate this formula. And let's try to do it. So what I have, what do I have? I have this dot A. I want to look for, I have this dot A and this dot V. Is that what I have? Yes. And then I have this dot, other dot A and other dot B. This is the equivalent of x1. This is the equivalent of 0.1 and then 0.2 minus 0.1. And then 0.3 and then 0.4 minus 0.3, I think. So the first thing I need, one thing you'll notice about this formula is the denominator here on both of these equations is exactly the same. So let me compute that as one thing. Equals y4 minus y3, oh, this is so hard, is, other dot v. Is y4 minus y3 is other dot v, x4 dot x. No, but it's y. Is other dot v dot y. So I need that times, and x2 minus x1 is this dot vx, right? Minus, I think this is right, help me along here, minus x4 minus x3, which is other dot v dot x. Is that right? Oh my God, this is so hard. Times, now I have y2 minus y1, which p2 minus y1 is this dot v dot y. How did I do there? Did you guys think I got this right? So I think this is a simpler version of that formula. Whew. Let's see what I do. Okay, now that's the denominator. Now the numerator, I'm going to say var, what's this 2 down here for? That's just like an extra thing. Okay, the numerator is var ua equals, let's just say numerator a equals x4 minus x3, which is basically we're calculating like the, anyway. x4 minus x3 is other dot v dot x times, now this no longer, y1, y3, these are actual points that I need to calculate. Here's the good news. Guess what? Here's the good news. So remember this goofy b? I actually also have, if I need it, this point over here, and I have this point over here, because that's what b is. I bothered to say, hey, this point a plus the vector, give me b. So I actually have the equivalent of x4, y4, and x2, y2. I have these in b. So b is x4, y4, and b is x2, y2. Hope I'm doing this right. Hard to keep track of. Okay, now, coming back over here, this is the hardest part of the whole thing, I think. Where am I? So b, so now I need to say, y1, this, y1 is a though. So y1 is this dot a dot x minus y3 is this, no, but that's a y. Y minus this dot y, sorry, this dot, other dot a dot y. So 1 and 3 are a and other. 2 and 4, 1 and 3 are this dot a and other dot a. 2 and 4 are this dot b and other dot b. And then minus y4 minus y3, that's other dot v. This is something that would be really good for me to just do in advance. Other dot v dot y. Oh my God, I'm losing my mind. And the other thing is I have like no space here. I got to just make this wider. Okay, other dot v, and then I need to look at this. Where am I here? I'm on the numerator here. So I just did x4 minus x3, y1 minus y3. Now I'm doing y4 minus y3. There's a pattern here. It would be better if I just studied this pattern. Times, and then what I need here is x1 minus x3. So what did I say x1 is? Guess what? It's exactly this. This dot a dot x, other dot a dot x. Okay, how's that for the numerator a? Let's look at numerator b. This is so much fun. How many viewers have I lost? Okay, now numerator b, one thing we should notice is these are the same. So that I can copy. It's just x2 minus x1 and y2 minus y1, which I want to change. Okay, so numerator b is actually the same, except x2 minus x1 is this dot v dot x, and y2 minus 1 is this dot v dot y. So I think I got this. There's a very, very high probability that there's a mistake there. I will be shocked if there's no mistake there. But let's start with this. Now, we're going to do the easier part now. If I got that correct, var ua equals numerator a divided by the denominator. ub equals numerator b divided by the denominator. It's a little bit misleading that I'm using A and B here because this A and B have nothing to do with that other A and B, but so it is. Okay, and then what I need to do is the intersection point var x equals, and I can reduce my space now. The intersection point is, what's x1? Somebody help me out. X1 is this dot a dot x plus ua times x2 minus x1, which is this dot v dot x. And then var y is this dot a dot y plus ua, notice ua times this dot, this, I don't know why I'm putting the parentheses in weird places. The order of operations should make it work, but just to be, this dot v dot y. How am I doing? How am I doing, everybody? Let's take a quick pause. Anybody want to point out an error that I got so far following this along? I'm going to take a sip of water. We're going to find out if I did this correctly soon enough. Okay. Cameras are shutting off. Okay, there's a good point in the chat saying, be careful because the denominator can be 0. So, okay. So I'm going to return to the video, little edit point there. Sometimes I think maybe it'll be easier to edit if I ding, like you could auto-detect where the dings are. Okay. So one thing, there's a very serious problem, which is that the denominator could calculate to be 0. And this is if those lines have no point of intersection, if they're parallel. I'm going to choose not to worry about that right now, let that error happen, and we'll deal with it later if it does. But obviously with an if statement, I could clean that up. But I am going to just leave that aside for right now. Okay, now, that will happen often. We're going to deal with that. Now, the other issue here is, but let's just see if we're getting some points of actual intersection. Oh, there's a really big point here, though, that I want to make. Look at all this time we spent calculating num b, the numerator b, and yet it's used nowhere in the formula at the end to get this x and y. Why is that? Well, here's the thing. There's a lot more to this algorithm than meets the eye, so to speak. Because let's just say, for the sake of argument, that these are my lines. Oops. So these lines have a point of intersection if you extend them out infinitely in both directions. So this algorithm will actually calculate this point. But that's not valid for me. I only want points that exist where I don't go backwards from the ray, only forwards from the ray. And actually, what's really wonderful about this is these UA and UB values will be negative if it's behind that ray, or positive if it's in front of. So one of the things I can do is I can actually say, this is only a valid endpoint if UA is greater than 0 and UB is greater than 0. So I can actually use this as a test. I don't even need to calculate just to know if two lines intersect each other. So, and I think I've got this right. We'll find out if I got it wrong, and I'll probably correct this later. Okay, so, and Alka in the chat makes a very excellent suggestion, which I could just do something like this. If denominator is, if not denominator, like if I could just say return. So, because 0 will evaluate to false. So let's leave that in there right now as a nice little protection. Okay, so what I want to do is I'm going to say this dot end equals create vector at xy. Because if I am searching to find the endpoint, I want to find where it intersects the vector, the other Henkin thing that's coming in. Now, I'm going to have to test which one's the right one, but this should give us something. So one thing I need to do now is I'm going to add this idea of an endpoint. And I don't actually need to add this up here, but I'm just doing this to keep track of things. And here I'm also going to say, if this dot end, I want to draw that endpoint just to sort of see where that is as well. So n.x, n.y. Let's make these just 4 pixels, and let's make this one like kind of a nice, some bright color so we can see it. So I just want to see if I have any errors in the code. Okay, still no errors in the code. Oh, I guess I need those to be bigger if I'm going to notice them. Let's keep them at 8. So and I should really make this, while I'm debugging, it would be much nicer to see this. This is just like a hard-coded polygon, but whoops. Let's just make it bigger so I actually have more to see. Okay, so now what I want to see is finding some intersection points. So what I'm going to do now is I'm just going to say in the Hankin function, after I calculate all the Hankins, I'm just going to say this dot edges index 0, find ends, this dot edges index 1. So I'm just going to test this function. I'm just going to say, hey, edge 0, which should be the top one, and edge 1, which should be on the one on the right. Just see if you can find the intersection points. So this should trigger this, which should then trigger 0 checking the other ones, H1 and H2, and we'll see if we find some endpoints. And then what I want to do is see what happens. So let's refresh this. Error. Polygon.js line 30. This dot edges index 0 dot find ends. Oops, there's just an extra parentheses there for no reason. There we go. Okay, so this is sort of a good sign in that this, you can see, if I zoom in here, this makes sense, right? This point here is where this ray would intersect with that one. It's the wrong one. I want that one to intersect, and I want this one to intersect over here, but we're getting kind of the idea. So, and then what's the other one I found? That's really weird. What is that intersecting with? You know what? It's intersecting with this one. So this is actually correct. So if you extend this out, right, I'm just testing to see if I'm finding intersection points between lines. Now I need these Hankin objects to actually optimize to the one that it finds first. So what I need to do here is in the Hankin object, what I want to say is if it finds an endpoint. Okay, so really what this is, where is this? This is not the endpoint yet. This is what I'm going to call a candidate. And what I want to do is I want to calculate the total distance of those candidates. The total distance, hold on. This is really hard. Let's get back to our original diagram, because I think we have this mostly working. So let's just think of just this one, okay? And eventually what I'm going to do is test its point of intersection with all of these. So I already had this diagram earlier, so I'm doing it again. It's going to intersect with this here. It's going to intersect with this here. It's going to intersect with this here, and this one, in theory, it's going to intersect all the way down here. This one is going to get ignored because it's not actually meeting this ray. So this will get ignored because I'll get a negative UA or UB. So I really just to know, is it this one, or is it this one? And I think a way for me to do this, one thing that's interesting is it's going to be equidistant here. So I could just test if these rays are equidistant or it won't be equidistant. That's an interesting possibility. I don't know if that's always going to be the case. I think it's perfectly symmetrical though. I'm trying to imagine if the polygon though is a weird shape. But I think I can also optimize for the minimum distance. So let's try kind of both of those. And see, so there's an error maybe on line 27. Let's take a look. Line 27 is a long one. I don't see, so hold on, pause. What's the error on line 27 perhaps, if somebody thinks there is one? I'm going to keep going because we'll find out if we're going to keep that in mind that there might be an error there. Okay. So here's the thing. If there is no end yet, then the candidate by definition is the end. So if n doesn't exist, then there we go. And now this should find the first one. So if I refresh this, you can see it finds the first one, right? This is working quite well. It's intersecting here, and then this one intersecting here. I'm not checking the other ones. So that's a good sign. If there is no, so now it's finding the first one. Now let's say it finds more than one. Let's say if end exists, however, and if end exists, one of the things that I need to do is I need to calculate those distances. So what I want to do is say var d1 equals p5 vector distance from candidate to what? This dot A. So remember I have A and other. So I have this and other, and I want to get the distance from the new point. So if I come over here, right, and this is the point I'm finding, this is this, and this one is other. I want to get this distance and this distance. So let's have a look here. And I want to get, so that's, I really need more space here. Let's see if I can just do that. And now I want distance 2, and I could probably move this a bit over here. Distance 2 is between candidate and other dot A. And the total distance equals d1 plus d2. So if there wasn't an end, then this dot end equals candidate. And guess what? I want to keep track of the previous distance. So I'm going to make that previous d another variable. And by definition then, this is the one I found before. This dot previous distance equals that distance. So if I haven't found an endpoint yet, that one's the endpoint, that's the previous distance. Otherwise, if d is less than the previous distance, then the previous distance is d, and I now have a new candidate, a new endpoint. So this is me. I'm going to check every single possibility and find the one that's optimal. Okay? I think this is pretty good. And now I'm going to hit refresh. And I've got the same exact answer here. Well, why do I have the same exact answer? Because I'm not actually checking everything against everything. I'm just checking the top edge versus that right edge. So I need to start actually checking everything. So the way I'm going to do that is I'm going to go back to the polygon object. Right? This is only where I checked this. I only checked 0 against 1. So what I actually want to do is write a loop that goes through all of the edges. And let me give myself a little bit more space here. Still not standing in front of it. Okay, go through all of the edges, and I'm going to do this. This dot 0 find edges, this dot I. Now here's the thing. I don't want to do this if 0 equals I. As long as 0 does not equal I, again, I'm only doing this for 0, so this is a little bit silly because I could just make that 1, but I'm just sort of figuring this out. Then find all the other edges. Okay, let's see. Hey, look at that. 0 found this one and this one. So this is working so far. I feel excited about this. Okay, now what do I need to do? I need to then not have 0, but I actually need 2 loops. I'm going to go through j. Every edge needs to check every other edge, and as long as I is not equal to j, then check I against every edge j. So this now should go through and check everything. Okay, syntax error, line 45. Wait, I probably just, why did that create an error? No, I have too many brackets. Okay, whoops, I lost my chat. Let's see. Or not enough brackets. There we go. Cannot read property h1 of undefined edge.findEdge. So somewhere there's an undefined edge. Okay. So let's see here. What is the issue? If I go into edges, and second loop should be j, not I. Let me take a look. Polygon. I'm in Polygon. Second loop. Oh, look at this. That's got to be j. Thank you. That's a big problem. Always with the I and the j. Okay, here we go. There we go. This is looking really promising. Look at that. So those points, it's found all the right points. I love seeing that. So now I'm going to come back. And actually what I want to do now is in Henkin, I want to draw this instead as Where's this? In the show function, I got a lot of extra stuff for debugging. So I can kind of get rid of that debugging stuff. And I actually just want to draw to this dot end. So now we should see this. So it got that star pattern inside the square. Wow, that's really exciting. Now, there's one thing I don't like that I did that I kind of want to correct, and then we're going to change the variables and do some tiling. One thing is that when I calculate that vector v, which I think I do in edge here, I think these should really be normalized because there's no reason, it's just things are going to maybe work better if these have a unit length of 1. Actually, this is going to work exactly the same, but somehow I feel like I should normalize those vectors. Normalizing a vector takes a vector and makes it of length 1. And let's just make sure I get the same result. Same result. Let's try some other angles. I'm a little bit afraid. Oh, I got to add the delta. That's very exciting. We're going to do that. So let's try some other angles like 30. There we go. Let's try some angles like 75. There we go. So this is working. This is very, very promising. Okay. Okay, so this is good. Now, let's add the delta. So if you recall, all of this was based on, where's the paper? All of this was based on this paper here. And right now, my midpoints are always exactly at the center. But what if I'm going to get some interesting possibilities if I offset from them from the center. So let's see if I can add that really quickly. Nothing is quick apparently, but I'm going to make a global variable called delta, and I'm going to set that equal to like 10, just to see. So where do I calculate those midpoints? In edge, perhaps? Midpoint here. So the difference is the Henkins now don't actually start at the midpoint. And you know what this would be? Let's normalize them here. And what I'm going to do, and actually what I'm going to do is, I'm going to do something a little bit weird. I'm going to set their magnitude to delta. Maybe I should explain what I'm doing now in a diagram. So if you recall, hello. If you recall, if this is my edge, what I first did is I calculated a vector that went from here to here. Then I'm normalizing it and rotating it to start that Henkin. But what I want to do is actually move the midpoint off this way by a certain amount. I already have this vector as a unit vector. If I scale it up by 10 pixels, I could just offset the midpoints in both directions. So let's see now. What I'm going to do is set their magnitudes. Then I'm going to say offset 1 equals P5 vector, add mid and V1. And then I'm going to say offset 2 equals mid V2. So I'm just going to offset each of those in one direction. And then, I can go back and normalize those vectors and rotate them. There's a lot of unnecessary steps in here and a lot of extra vectors, but I'm just trying to work it out. Okay, so now the midpoint, I should start with offset 1 and offset 2 instead. Simple as that. I should have the delta in there now. So guess what? I sent them in the wrong direction. See how this one went up that way, and this one went this way? They should go in the other direction. So interestingly enough, what I want to do is for offset 1, I actually want to add V2, and for offset 2, I want to add V1. And there we go. So now we can see that delta is there. Wow, this is great. Let's make some sliders so I can change the angles in the delta to see if everything's good. So what I want to do now is I'm going to just go to the main program, and I'm going to say delta slider and angle slider. And I want to say delta slider equals create slider. Let's give it a range between 0 and 25. And let's start at 0. And let's make, and these are P5 DOM functions for quick, easy ways to make sliders. And angle slider, we'll make a slider that goes between 0 and 90 degrees. Just for simplicity right now, and we'll start at 60, which is sort of a value that I started with. And then, now here's the tricky thing. I'm doing this just once, but we're going to have to recompute all the Henkin stuff whenever I change delta and angle. So let's just add a draw function and see what happens here. It's still working. Now, I can do this. I can change these sliders, but what I want to do is I want to say angle equals angle slider dot value, and I've lost my train of thought. Angle and delta equals, I've lost my choo-choo coding train of thought. Where's my train whistle? I can't find it. Equals delta slider dot value. Okay. Doesn't like me to do that. Cannot read x. So let's just make sure it's getting actual values there. I have to build a, okay, hold on, let's see. 60 and 0, do those values actually work? Let's make it start at, yeah, that's what, 75 and 10. I know those values should work. Angle is angle slider. Am I doing that right? Angle slider. Delta is delta. Ah, there we go. Ah, so there was something went wrong with 0. Right? If I change this, oh, whoops, I need a background. That's kind of nice. So let's add the background here. Okay. I think I'm converting it to radians. So this is working, right? I'm changing the delta. It broke when the delta got to 0. So I have to investigate that. And the angle is changing. So this is working. Why should it break when delta gets to 0? Oh, it shouldn't break when delta gets to 0 because that should just be what I started with. But it is breaking. So let's see if we can fix that. I mean, so where am I using delta? I'm only ever using delta in edge, right? You know what? It doesn't want me to set a magnitude of a vector to 0. That's going to break everything. So what I can do is I can say as long as, so only if delta is greater than 0 should I bother doing this offset stuff. Otherwise, so I have to kind of, I'm just going to say offset 1 equals mid, offset 2 equals mid. So I just say, there's I'm sure a much nicer, more efficient way to write this. I will think about that later. And then, right, so I'm creating those offset variables, and they're just the exact midpoint. And then only if delta is greater than 0 do I bother to actually offset them. So now I should be able to slide the delta down to 0. No problem. I can change these. Look at this. So now here we go. We are going to do something a little bit more exciting. I just have the whole point of this, right? If I go back to this paper, is that I want to create tiling patterns and tile them and then get all this stuff going inside of the tile. So I'm not going to go crazy with this, but I'm at least going to tile a whole bunch of rectangles. So let's go back. And now it's easy. Now that we've got this working, remember I did this with just one polygon. So I'm going to change this now to var polys is an array. And I'm going to say for var x equals 0, x is less than width, x plus equals, and let's do an incrementation value. Let's say 50. Let's say 100 for right now. X plus equals increment. I'm going to make a nested loop to make a grid of rectangles. Y is less than height, y plus increment. Then I'm going to say var poly equals a new polygon, and I'm going to add x, y, x plus increment, y, x plus increment. So I'm now doing all the vertices, y plus increment, and then x and y plus increment. So this should do poly close and then polys dot push poly. So what I've done here is I've looped through all of the polygons, all of the spots on a grid, and created a polygon for each one. So I'm just thinking of the window as, as a grid. And I'm saying make the first polygon here, to here, to here, to here, close it. Then go over here, to here, to here, to here, to here, to close it. Then go down here. And I probably went here, to here, to here, to here. But the point is I'm iterating over all the spots and making polygons. Now, in here then, all I need to do is say for var I equals 0, I is less than polys.length. One of these days I'll use a for each loop. And now I'm going to say polys, I'm going to do this, I'm going to recalculate the Henkins for every single one and call show for every single one. Let's see if I got this. Line 39. What's missing here? What's missing? I'm missing a closed bracket here probably. Yep, I never closed setup. So now we can see I now have my grid. Ooh, some weird stuff just happened there. I might have a little mistake. I don't want to find out. No, I don't know. It just sort of depends on the angle and the offset and that sort of thing. Oh, something is slightly broken there. So I'm going to investigate that later because I think we got pretty close. Whatever code that I publish, I'm going to debug and fix that. I have a feeling my test for finding the closest one has a little bit of a flaw in it. But you can see here that I'm able to start getting these patterns. So this is now completing, essentially, with possibly some minor bugs I will fix, you'll find. Maybe I'll do a follow-up video if it's something really major. But usually it's just an edge case where if it's too far apart or something like that. But what's missing from this are two things. One is a different tiling pattern than just this grid of rectangles. So what happens, for example, if I do heptagonal tiling? So we can see these. What happens if I actually try to create a tiling pattern like this and then fill it with those stars? Or even just something like this and fill it with the stars. If you look at the paper, it will have many examples of different tiling patterns. Can you create this tiling pattern or this tiling pattern and then iterate and create all of the Henkins inside of it? It's showing you different angles, different tiling patterns. And so ultimately, it probably would make sense to come back and do another video with some of these tiling patterns, but I'm hoping that some of you might be able to contribute some of these tiling patterns to the GitHub repository. So that's number one. The other thing is, what I've done here is I've just calculated all the points, but I need to also put those into some form of list so I can draw them using begin shape and end shape so that those could be filled with color. Because I think there are probably some beautiful ways that you could then color all of the different aspects of this. So that's what I'm hoping. I'm going to link this code in this GitHub description. I hope that you enjoyed. I hope that we can fill the world with beautiful star tiling patterns modeled after many beautiful Islamic patterns throughout history and other patterns from other cultures as well. I'm going to put a lot of links in this video's description for different references and books that you can look at to find more inspirational patterns. And I'll see you. I'll come back and maybe do a follow-up video showing some things that people have made or contributed. And I will see you in a future coding challenge. Thanks for watching. Okay. So I don't know if I Am Some is watching right now, but I kind of want to, I might do an addendum. First, I need to do the intro to this, where I talk about some of these good causes to donate to, and show the end result. But I'm curious, I want to sort of look and see, this is the one that I did earlier. Let me just look and see how I did this find function. It's done differently. I'm also checking so actually, the way that I did it in the previous one is actually just checking if their distances are identical. That's right. By not finding and I'm also trying to make, so let me just see for a second here. Because I wonder if I add that check in, I did mention that, in Henkin here, where is that? If d is less than previous d and the difference between those distances is very, very small, like they're equal. I didn't want to test if they're exactly equal because there'll always be floating point rounding errors. This is the wrong one. Oh, whoops. Whoa, what happened here? What did I do? Oh, I have a mistake in my code. Ampersand. So let's see. No, this, I think it's just like maybe if the angle is too low, why does it not find itself anymore? So I have to, let's look at my other one. Let's see. So I don't seem to have that problem with this one. This is the one that I did earlier with some help from me-I-am-some. So there's definitely just a little bug. Needs to be for both the branches. Aren't I doing that? Aren't I doing that? Okay, let me look at the other one. Oh, do I actually just assign it as the end to both of them in the one that we did earlier? Where is this function? I don't see any difference here. The absolute check for both branches, I mean. But isn't that by definition happening because it is, I'm looking at both chats. The read from the random number book, I know. Hold on, this camera went off. The other one's going to in a second. Okay, so let me think about this. This is the one I did today, live. And this is the one I did earlier. Oh, even for the first one, I don't have my test in both places. I see. Oh, you wrote this. If previous is undefined, it can join to a line that is not equidistant. Got it. Okay. Let me live. Henkin. Wouldn't there only be one that's equidistant? I guess I need to, but anyway. So it's only valid altogether. Well, I guess I can just put this in both places right now just to see. Oh, this is not. That's from earlier. This is from today. I don't see any mistakes now happening. Aha, there we go. I better come back to that video. I don't know. I think Mathieu probably had to go. I don't know if he's still watching, but I think what I might do is do a quick addendum now. I do this often where I come back to that video that and sort of correct that bug. Or maybe I could insert it. Could it be inserted? I don't know. Mathieu will do some clever editing. So I'm going to add that now. Me, I am so, oh, me, I am so me. I'm only saying me, I am some. Sorry. Me, I am so me. I am so me, me. I am so me too. For better or worse. Okay. Okay. So we're gonna, okay, so I'm gonna come back. I'm gonna add this to the end of the video. Okay. Let me get rid of that unnecessary console log. Where's that happening? There it is. Okay. I'm back. Guess what? That was actually, there's a little bug there that the chat helped me fix. Me, I am so me, once again, from the chat, helped me fix this one. So there is a bit of a property here that, that's important to consider, which is that if I'm going to have these, find that intersection points, they're always going to be equidistant from those edge points, even if I'm moving with delta or whatever. So one thing I could do to double check that I'm really finding the right point is make sure that these two line segments are of the same length. And so what I'll do for that here is if I go back, so we can see the problem. The problem is there's some weird, oh wait, why is it working now? Timeout. Did I not hit save? Oh, huh? Where am I? Whoa. How do I make it not work again? Oh yeah. Okay, hold on. I'm gonna come back. Oh, Wichman. Christian Wichman. Is it Wishman? Wishman? I'll come back to that later. We're gonna, yeah, help me with pronunciation later. Okay. This is no band, no wall, no grid. Yeah. Oops, wrong. I almost hit the video accent. Okay, I'm gonna come back. I'm gonna do my, there we go. I'm gonna do my pretend walk back for Mathieu to edit. Okay, so if I look back at what I was doing earlier, look back at what we just made, is you can see there are these glitchy parts. See these glitchy parts? It's finding some weird nonsensical points because it minimized the distance in a way that's not exactly right. So what I could do here is I have this distance, D1 and D2. So I just want to check if those are equal. And I could just say, as long as they're equal, and that would maybe work, but with floating point math, you're often not going to get two values being exactly equal. So really what I can do here is just look at the difference as the absolute value of D1 minus D2. And I'm just like not even going to bother with any of this stuff if the difference is not less than 0.1 or something. That means they're equal. So what this should do is like, don't even bother going through. And again, I could probably make all these sort of nested if statements a bit nicer at some point. But I'm just going to not bother. It's not a valid endpoint if those aren't equidistant. So now if I hit refresh and I play around with this and change the values, I can't break it anymore. And we should be ready to move on to the more interesting tiling and coloring part. So I hope you join with me. I hope you I don't know what I hope. I hope that people are nice to each other and kind to each other and welcoming and tolerant of each other. And I hope that you consider contributing to this GitHub repository with a suggestion, with a pull request, and make some beautiful tiling patterns and share them with me in the comments on Twitter at Schiffman. And also, if you find a particular tiling pattern from history that you're aware of or you know about that I don't know about, tweet me a picture of it. I'm always inspired and enjoying sharing. So, sharing tiling patterns. So, okay, I'll see you soon in a future video, perhaps. Goodbye. Yeah, Nuno makes a good point. Would that fix work for all shapes? So please get rid of the grid. Yes. Wait, I'm back. I totally forgot something really important here. The whole point of this is to get rid of the grid. This video is a never-ending video challenge. The whole point of this is to get rid of the grid, which I could do very easily right now by in the polygon show function, in the edge show function, right? I could just comment this out. So if I am only drawing the star patterns. This was the whole point of doing this in the first place, but what I also might do, just to have a subtle reference to the grid, if I ever needed to, is just give it some nice alpha, and you can kind of see it there. 50 alpha, it's sort of subtly in the background. So this, by the way, is an important aspect to consider as you start to make your own creative takes on it, and for debugging and giving options, you want to see the grid, not see the grid. And I am not sure, but I would not be surprised if there are bugs are going to be revealed, that are things I didn't do correctly if you expand to a more complex tiling pattern. So I hope we can discover those things together, and I will definitely, if there's a significant issue with this, come back and follow up in a future video, and I'm sure I'll hear from you in the comments. Okay, I'm really, really leaving this time. Goodbye. Okay. Okay, sorry, thank you about that. Weekman. Christian Weekman, yes? Okay. If the gloves fit, remove the, okay. Thumbs up for grid removed. Okay, and the grid is back. Sorry, everybody. No, it's gone. Wait, one more thing. Okay, so what do I have? The thing that I want to do now, if some of you who might have joined late, is I would like to, I'm making this video and donating to support refugees and welcoming refugees and immigrants to this country where I live. So I'm just going to do a quick, I'm going to record a quick introduction to this video. I feel very awkward, like somehow like this is making me, I'm not used to doing this, and I'm like awkwardly trying to not say this in a silly way. So I'm going to just make a really quick two-sentence introduction, and I am also going to, I want to make sure I have a reference. I could do this, but I would actually like to look at I'd like to pull up interlace patterns. Wow, these are beautiful interlace patterns. No, I want star patterns though. That's what I did. Why can I not find that on Wikipedia now? Wasn't I just looking at a Wikipedia page? Pedia. Maybe it was just this. Yeah, because this has star patterns in it. Copy image, preview. Can I get all this on the screen? Okay, can I minimize this? Can I put this over here? Now, can anyone help me in the chat? I want to be able to, it's very important to me that I'm doing this in a culturally sensitive way, and I'm not that familiar with a lot of things about Islamic culture. But so let me know if I'm saying something wrong or inappropriate. So this is from the Bibi Kanu Mosque in Samar in Uzbekistan. And so I think I will, and I want to find out what year this is. So does it say, I'm curious what year this would be from. Does anybody know, first of all, if I pronounce that incorrectly or incorrectly? Bibi Kanu Mosque in Uzbekistan, and if anybody knows, I wanted to what year this is. So let's look up. Let's click on this. This mosque is history, maybe in 1399, completed in 1404. So, okay. So, oh, look at this. And you can see it right there. This is actually maybe even a better image. But that's beautiful. 1404, thank you. So I'm going to remember that. And, okay. And I'm going to stand over here. Okay. And I'm going to do a quick introduction. And anybody, you guys give me feedback after this? Because when there's an edited video that gets uploaded, this will be the thing that will be at the very beginning of it, okay? Okay, now, wait, one more thing. Owen in the chat is making an interesting point, which is to say that I'm not picking something from a country that's listed on the particular ban that I'm very much against personally, but I think it's okay to just use this as an example. So, and I hope that I'll mention that people should submit other examples in the comments of beautiful tiling patterns that you want to reference. So now I already forgot what this was called. It is the Bibi Kanu Mosque in Uzbekistan from 1404. But if anyone has a suggestion right now for a different suggestion, please let me know. And be nice to each other in the chat, please. I don't know what I'm making happen here on the internet. Okay. Okay, so, whoops. Let me just remember what it's called again. Bibi Kanu Mosque in Uzbekistan, 1404. Okay. Okay. Oh. People are giving me, yes, I'm just going to say this for 1 second. I realize that some of you tune in as an escape from the many problems of our world and just to learn about programming. And I will return to my regular schedule, just doing coding challenges and making goofy sounds with the train whistle. This is a bonus. This is a bonus episode on Tuesday. This is in addition to the once a week live stream that I will regularly do. And to me, I feel like these are some very good causes to help people in the world who are trying to escape a lot of real problems. And you can bear with me. You can turn this off if you want for today. Okay? So here we go. It's so weird to stand all the way over here because I'm so far away from the camera, but I think this will work. Okay. Hello, welcome to a special bonus coding challenge. This coding challenge I'm doing on an extra day this week in support and in solidarity with refugees and immigrants from around the world, in particular against the recent ban. See, now I'm like, my awkwardness is catching up to me and I'm going to have to do this multiple times. Okay, I'm going to do this one more time. Okay, here we go. I'm really just going to get through this once. Okay. Hello and welcome to a special coding challenge. This is a special coding challenge that I'm doing actually to celebrate, in some ways, 200,000 subscribers. And I also want to do this as a bonus coding challenge in solidarity and support of refugees and immigrants. I'm not interested in any walls, and I'm interested in welcoming. And so to celebrate 200,000 subscribers, I'm donating $200 to each of these worthy organizations that will be linked in this video's description. And if you watch this video and enjoy it, if you feel inclined to donate, that's great too. But I'm happy to do this video in support of these wonderful organizations. Okay, now what's in this video? This is an example of an Islamic tiling pattern. Now this is from Let me say this. Matthew will edit. Bibi Kanu Mosque. This is from the Bibi Kanu Mosque in Uzbekistan. It was completed in 1404. And what's amazing about these kind of patterns, if I zoom into it, let me zoom. It's actually a higher resolution image, is you can see this amazing algorithmic tiling geometry. It is beautiful. And what's amazing about this kind of stuff that you can find, and there are countless examples of this in many cultures for many thousands of years, these algorithmic geometric tiling patterns that we work out code or mathematical formulas from, people have thought about and done very carefully by hand. So in art and architecture throughout history. So I would love for you to share in the comments your favorite historical geometric tiling pattern, and I'll maybe come back and do future coding challenges. There's a great book called Symmetry. I don't have my prop here. Someone can like Photoshop in that book. I have it downstairs. Linked about this book in this video's description, which also has lots of wonderful examples. So in this challenge, I'm going to try to implement an algorithm that, that generates a styling pattern like this. Cut. I just want to make sure I have sorry, Mattia. I want to make sure I have it open. And so I have this. And I have, where do I have the paper? I do not. When we go to preview, I don't have the paper. Let me minimize this. Okay. Okay. I will mention all the addendums, thank you. Maybe I've said some things wrong. After I finish that, I'm happy to hear if I said something incorrect, and I apologize that I do this thing where I don't really prepare and I just kind of look stuff up, and I apologize if that bothers you. Okay, I shouldn't look at the chat. Okay, here we go. Okay, what was I saying? Okay. So the algorithm that I'm going to take a look at comes from this particular paper. You can see here, look at these geometric possibilities. In a minute, when I start the coding challenge, I'll show you more about this paper. And in the end, what I'm going to have is something that looks like this. So I'm actually recording this after I finish the challenge. So you can see this is me first being able to sort of generate and create different patterns that approach this idea of these star patterns with some different parameters. So a couple things to mention. This is a particularly long video. This is a complex topic. There's lots of things that I skirted over that I should probably make some separate videos about. I also, at the end, finished the video and then thought of and fixed a bunch of bugs afterwards like 2 or 3 times. So if you really are interested, watch all the way to the end. There'll be a couple addendums. And then what I'm asking you to do is share in the comments what you share in the comments, other interesting tiling patterns that are beautiful to you, that might be worth investigating in future coding challenges. And also check out the GitHub repository that'll have a link to this particular example running online, and I would love for people to contribute to it, and we'll make it a bit more sophisticated. And when I come back for my regular live stream this Friday, I will follow up and show you hopefully some more exciting and interesting examples of colors and patterns with this particular algorithm, okay? So thanks for tuning in to this coding challenge on the coding train, and see you at the end of this video. Goodbye. Okay, all right. Okay, so there we go. Yes, so it's almost 6 o'clock. I'm really late. Hopefully, so I have to go. This has now been a 2-hour live stream. And I know I spent about 20 minutes at the beginning and probably just about 20 minutes now. So that video might be a full hour long of that coding challenge. It probably should be divided, but I'm just going to leave it as one. This is a special extra video. Anybody, was there anything about that intro that I can always come back and re-record it tomorrow. So if anybody has any, hopefully it's fine. Okay, so I'm gonna leave because it looks to me like the chat is getting quite off topic. I appreciate that everybody has passionate thoughts and ideas, and we will return on. So what I'll say again is my regularly scheduled coding live stream. I am now hoping to have a regular time slot every week that you can always rely on. It will be Friday. I'll start sometime between 10 a.m. and 11 a.m. Eastern Standard Time on Fridays, and you can always check Twitter. Now, I'm sure there will be Fridays where I can't do it, and so I will continue to use my mailing list or announce on Twitter. You can subscribe to @Schiffman or @The Coding Train. And thank you for your support. Thank you for watching. I know that folks are maybe disappointed. I'm surprised that folks are disappointed that I didn't do my dramatic reading from this book. I'll just give you a sneak preview, a teaser, so to speak. 87,224. 91,852. 71,534. 3,487. 36,163. 18,648. 83,848. 49,887. 47,982, 60,500, this is actually kind of nice, 60,587. Anybody want to auto-tune this? 80,024, 16,284, 53,246, 93,966, 64,000. But anyway, I have to go because I got to get home for dinner and children are waiting and I've spent way too much time here. But I will come back. I would like to read all of page 200 to celebrate 200,000 subscribers. And I've kind of said that if I ever get to 1 million subscribers, I don't know if I should promise this, I'm going to read the entire book. Is there some, can I like cross my fingers behind my back just in case that's not a medically good idea to do that? Like it would take a week, but that's sort of my desire. Let's have you record these at a very specific pace, Alcorites, and then we can put it into a neural network and generate more random sequences based on your voice. I could also I've got the, yes. Kay Weekman in the chat says, sounds like you've got the edition with the typos in it. Questionable legal issues. Yeah, I have to check if this is in the public domain. It's a very good point. Audiobook. 1 million random digits, the audiobook. I'm going to read some more of this to you guys on Friday. I might come do a bonus episode on Thursday afternoon just to read this. Let me know how interested in that you are. Okay, thank you everybody for watching. I'm going to play my ridiculous intro video on the way out, because I didn't play it at the beginning because I didn't feel so good about it. But now I feel like I'll play my intro video. And so after when it's over, I will say goodbye. I'm reading the chat while I play this.
up in the air and say enough's enough. Do you want to learn to code and make some awesome stuff? Learn that anyone can when you're coding with Dan on. Whether you're a pro or this is all brand new,
Coding Train has some helpful tools for you.
learn the overarching concepts and some fun stuff too. And with Dan as your guide, come along for the ride on
The Coding Train.
Make a crazy pixel mirror to reflect your face. You can make it jump to light speed into outer space. You can generate a maze that can go on for days. You can make your own terrain and some purple rain. You can make a retro game to see how it's done, and then tweak a piece to make it yours for everyone. Make some fractally trees or Twitter bots if you please. And when the seeds are all sown, you can make them your own on
Coding Train.
Ride the colors of code, you can follow the road to
Coding Train. Bye. I have to come back up here for the mouse to hit the button to stop streaming. Bye, everybody.